Welcome to The Explainer. Today we're tackling a huge question that could totally reshape the future of AI in warfare. How do you teach a machine to say, "I'm not so sure"? It's an idea that really gets to the core of whether we can ever truly trust artificial intelligence.
Okay, so let's just dive right in. The central problem here is a classic trade-off: speed versus safety. You see, militaries run on something called the OODA loop. That's observe, orient, decide, and act. And to win, you have to get through that loop way faster than your opponent. Now, AI promises unbelievable speed, but that brings up a massive question. What's the real cost of letting a machine make a decision that could lead to, well, destruction and death?
And look, this isn't just some technical problem for engineers to solve, it's a huge strategic one. According to military researchers, before we can even think about putting AI into critical combat roles, we've got to deal with three major roadblocks.
So what we have is basically a crisis on three fronts. You've got ethics, you've got budget, and you've got trust. The moral questions, they're profound and pretty obvious. The cost is absolutely massive, so you better be sure the payoff is real. But honestly, the thing holding it all together, or letting it all fall apart, is trust. If you don't have that, the whole promise of military AI just gets crushed by its own risks.
But what if we could teach AI to tell us how doubtful it is? This is where a really fascinating concept from the science of measurement comes into play. It's called uncertainty quantification, or UQ for short. And it might just be the key to unlocking all three of those big problems.
At its heart, UCQ is basically a language of confidence for machines. So instead of just a black and white yes or no answer, an AI with UCQ gives its output along with a confidence score. It's the difference between an AI saying, "That's a target," and it's saying, "I'm 99% certain that's a target," or maybe, "I'm only 60% certain." And believe me, that one little difference changes absolutely everything.
The easiest way to think about it is like a weather forecast. You know when it says there's a 70% chance of rain? That number isn't just a random guess. It's a carefully calculated expression of how uncertain the model is. And this whole idea comes from metrology, the science of measurement, where it's understood that any real measurement actually has two parts.
And this really gets to the core of it. Nothing is ever 100% certain. Every single piece of data, whether it's from a satellite photo or a sensor on a drone, has some level of uncertainty baked right in. UQ is the framework that takes all that hidden uncertainty and makes it visible, makes it something we can measure, and, most importantly, something we can actually use.
So how does this kind of abstract idea solve those three huge real-world problems we were just talking about? Well, it gives us a practical framework for action. It turns these philosophical debates into engineering problems that we can actually start to solve.
Okay, let's break down how UQ hits each of these pitfalls head-on. For the ethical problem, it lets commanders set the rules of engagement ahead of time. For example, an AI might be cleared to track a target if it's 75% sure, but it can't actually take action unless it hits, say, a 95% certainty threshold. For the cost issue, it gives developers a clear goal: make the system this reliable. It connects the money you spend to results you can actually measure. And for trust, it's a total game changer. It creates transparency, so the human operator always knows exactly how confident their AI partner is feeling.
Let's walk through a real-world example. Imagine a remotely piloted aircraft. An RPA is tracking something. Now, every part of its system has a little bit of uncertainty. The sensor's calibration isn't perfect. Let's call it 98% certain. The video feed is super secure, but maybe there's a tiny 1% chance it's been messed with. And the original intel it's working off of is good, but it's only about 85% confident. So UQ takes all of those numbers and mathematically propagates them, rolling them all up into one final confidence score. In this case, it comes out to 82% certainty. Now the human commander has a clear, data-driven number to help them make a decision. At the end of the day, this isn't about trying to build flawless, all-knowing machines. That's just impossible. What this is really about is building effective human-machine teams, where each side understands the other's strengths and, just as importantly, their weaknesses.
And this is the key mental shift we have to make. We need to stop thinking of AI as just a tool, like a fancy hammer, and start thinking of it as a teammate. So what makes a good teammate? Communication, right? A good partner is honest. They tell you what they know for sure, and they're upfront about what they don't know. UQ gives an AI the voice to do exactly that.
What's really cool is that this approach isn't just some good idea floating around. It lines up perfectly with the Department of Defense's own ethical principles for AI. It makes AI responsible because it's designed to inform human judgment. It makes it traceable because all this data is tagged and you can follow errors back to the source. It makes it more reliable because it shows developers exactly where the weak spots are. And it makes it governable by setting clear guardrails for what the AI can and can't do on its own.
Okay, so as promising as all this sounds, putting uncertainty quantification into practice, well, it comes with its own set of very real, very difficult challenges. It's an incredibly powerful tool for sure, but it is not a magic bullet.
So what are the hurdles? Well, first, how do you show 82% certainty on a screen to a pilot in the middle of a dogfight without just confusing them? That's a huge design problem. Then you have the fog of war issue. In these massive strategic models with thousands of moving parts, all the tiny uncertainties can pile up on each other until the final result is basically 99% uncertain, which is just a fancy mathematical way of saying we have no idea. And finally, you have us, humans. We have our own biases that might make us ignore a 70% certainty if we really, really want the answer to be yes.
And this really brings us to the core takeaway, which I think is captured perfectly in this quote. The goal here is not to get rid of uncertainty, because in war, and frankly in life, that's impossible. The goal is to understand it, to manage it, and maybe even, as Hammond says here, to revel in it.
So let's be clear. Uncertainty quantification isn't about creating machines that make perfect decisions for us. It's about building machines that can be transparent and reliable partners, giving human commanders the clearest possible picture of a situation, including an honest look at what the AI doesn't know. The point is to augment our judgment, not to replace it.
You know, by giving our AI systems this language of uncertainty, we're doing more than just solving a tech problem. We're creating a totally new kind of partnership. We're building a path toward a more transparent, more responsible, and more trustworthy future for human-machine teaming. So the real question this leaves us with is, how are we, the humans, going to adapt to that?